One of the challenges in risk analysis is learning to recognize the difference between the source of an uncertainty, the so-called chance event, and the consequences of that uncertainty. This particular scenario is sort of an invitation to practice that. Let's look. Regional Disaster Relief Services provides emergency assistance during natural disasters. Okay. The manager of Regional Disaster Relief Services Warehouse Number 4 has instructions to deploy emergency shelter for people displaced by a fast-moving wildfire. Travel time to the site is 7 hours. Now see, I've already come across data. I'm not very sure yet what we're going to be doing. But loadout depends on the number of volunteers responding to the warehouse. Okay, RDRS alerts its volunteers through text messaging and waits about an hour. I'm being quoted data again about time for those who can help to arrive at the warehouse, an interval known as turnout time. Interesting, I'm being quoted time intervals and names for the time intervals. If the usual number of volunteers appear, loadout takes about 4 hours. There's another interval. However, if the turnout is rather poor, loadout takes twice as long. Okay, sometimes the turnout is distinctly good and loadout takes half that time. Again, these are comments on certain amounts of time. First off, first question, what is the chance event with distinct future states of nature that concern the RDRS manager? All right, so just in that story, we need to tweeze out, now wait a minute, the chance event. A chance event is a source of uncertainty. All right, and in classic decision analysis, that uncertainty can be thought of as several different alternate futures, only one of which is actually going to happen. So if this is applicable to the paragraph that we just read, that means in that paragraph somewhere there has to be something that the manager's not certain about and that it's being spoken about as essentially this could happen, one of the futures, or this could happen, another one of the futures, or this could happen, the third one of the futures. These are the so-called future states of nature that are associated with the chance event. All right, so to answer this question, we have to verify that. We have to go find that. So what is it that the manager is not certain about? The manager's just been told to get ready to deploy emergency shelter. Okay, what is it here that the manager doesn't know for certain? Okay, loadout depends on the number of volunteers, usual number of volunteers, distinctly good number of volunteers, rather poor number of volunteers. The volunteer turnout is the chance event. Okay, in this one paragraph, the paragraph mentions emergency shelter and wildland fire and travel and whatnot, but the only thing in the paragraph that it's actually specifically volunteering as kind of not being known, and there's like a couple different things could happen, is just this issue of when you call the volunteers, how many of them are going to turn out. Now, that is the chance event. Chance events always have these future states of nature. What exactly are the future states of nature that were mentioned here? Oh, that's the business about a usual turnout versus a, oh, wait a minute, rather poor turnout, versus what was another one that was mentioned, sometimes turnout. There's another, sort of indicator of uncertainty, distinctly good. These are the future states of nature. Oh, all right. So actually, Dad answers that. Now, wait. To finish this off, what are the consequences of those future states of nature? Because this is another convention of classic decision analysis. You have the source of uncertainty. That's a chance event. Okay, it's basically splitting your future off into a couple different futures that could happen, only one of which is going to happen to you. You just don't know which one. Fine. Oh, each one of those futures has a certain value. Okay, it may be valuable value or it may be cost, but it has a certain value or a certain consequence. All right, now, recognition. What is the consequence of volunteer turnout? Well, first off, volunteer turnout, why don't we just get organized here? I'm going to list the future states of nature. And I'm going to order them here, not the order they were mentioned in the paragraph, rather poor, usual, or distinctly good. I'm guessing at their desirability, and that's how I'm ordering them. But nonetheless, okay, there's the 3 future states of nature. Now you say, well, there was the issue of, no, wait a minute. Loadout. Loadout depends on the number of volunteers. Oh, all right, this is how long it takes them to actually load up the stuff. And right, that's what was varying. Okay, because it said if the usual number of volunteers appear, loadout takes 4 hours. If it's rather poor, it takes twice as long as that 4 hours. If it's distinctly good, it takes half the amount of time as that 4 hours. Oh, that must be the consequence. Oh, okay, well then we would just, note that. We'd say, all right, loadout. Usual amount of time, 4 hours. Rather poor, it says twice as long. 4 times 2 is 8. That's where I'm getting 8 hours. If it's distinctly good, like a bunch of people show up, then it could be done in half that time. So 4 divided by 2 is 2 hours. You say, oh, well, okay, there's your consequence, right? There's the one thing that varies, right, as a result of these different futures. I wouldn't leave it here because that is not the best answer to what's the consequence, especially if you talk about the reality of what the manager's perspective. The manager has been asked to deploy emergency shelter to evacuees. The real issue here is how fast will that get done? When will the emergency shelter actually arrive? What is the ETA, the estimated time of arrival of RDRS at the scene? Now that is related to this. It's being driven by this, but wait a minute, there was some other data. There was mention of 7 hours here for travel and waits about an hour. We never used that. Oh, right, because ETA is, what did they say? First you have turnout time. Then you have loadout time. Then you have travel time. This is not like an official formula. We're just piecing this together from the description of the situation. So your estimated time of arrival at the scene is, well, it's going to be these 3 things. It's going to be these 3 things. Turnout time is 1 hour. That's what they said. Travel time is 7 hours. Right, the uncertainty is right in here with the loadout time. You know what? We better clarify that. This is really the consequence. It's of concern to the manager because this is probably what the manager has to report to the people requesting the shelter. What will the ETA be? Okay, well, if volunteer turnout is rather poor, you're still going to wait the 1 hour, plus it's going to take 8 hours to load up, plus it's still going to take 7 hours to travel. What's that work out to be, 16 hours? Estimated time of arrival on the scene, 16 hours. Versus usual, if the volunteer turnout is what it usually is, still wait 1 hour for people to turn out. It's going to take 4 hours to load up. It's going to take 7 hours to travel. That is a total ETA of 12 hours. Right, plus if it's distinctly good, you still wait 1 hour for people to show up, 2 hours to load up, and then 7 hours to travel. 10 hours. That is the best expression. It's not that the loadout time, as far as being the consequence of future states of nature, it's not that that was strictly wrong. It's just that actually this is more to the point. This is the consequence of the one thing that the manager's not certain about, and that's how many people are actually going to show up.